remember that these are random code books, and remember what I said originally, which is that the code books, the probability of the code books is invariant to row permutation. That's because it's IID. Every element of the code book is IID, so if I exchange two rows, as far as the probability of that code book is concerned, it does not matter. So, is it, given that I can exchange rows, in other words, exchange code words all I want, is it possible that this sum can depend on W? Excuse me, this average ends up depending on W in the end. No, because I can permute this all I want. In fact, I can replace this with pi W, some random permutation of the code words. And because row permutations in the random code book don't matter, this sum must be invariant to that permutation. So without loss of generality, I'm going to pick W equals 1. So this is for convenience. All of the code words are the same. So what I'm going to do is I'm going to assume that code word 1 was sent, and all of the other ones must be equal. So I'm going to say sum over C, PC, lambda W at C is equal to the sum over C, P of C, lambda 1 of C, because the code books are indistinguishable under row permutation. So that's all of, in other words, all the messages, the average probability of error over all the messages, or over any message, is equal to the average probability of error for the first message. So for convenience, we're just going to assume that the first message was sent. So this is actually why it's really easy to deal with random code books, because we just got rid of the dependence of, now we don't have to worry about which message was sent, and we don't even have to worry about the structure of the code book, because this is the same. So we're going to say, let's let this be the probability. I'll give this a special notation. That's the probability of error given that word 1 was sent, or message 1 was sent. So this becomes 2 to the minus nr, sum from W equals 1 to 2 to the nr, of this, which is probability of error, given that the first code word was sent, that the first message was sent. Now, this is no longer dependent on W. So I'm summing over 2 to the nr possibilities of something that doesn't depend on W. So I end up with 2 to the minus nr, 2 to the nr, probability E given W equals 1, which is equal to the probability of E given W equals 1. Okay, so in other words, the average probability of error over all code words of all code books is equal to the average probability of error of all code books, given that the first message was sent. So the purpose of this exercise was so that I have a code, I have a message to deal with, and that is message number 1. Turns out any other message will be the same, so therefore the average must be the same. Okay, let the event Ti represent the event that xi and the received vector y from 1 to n are in the jointly typical set. So remember, this is the notation for the jointly typical set. And that's valid over any I in the message set. In other words, this is Ti occurs if, whoops, that's not x sub I, that's x brackets I. xi and y from 1 to n are jointly typical. Notice that, remember my decoding rule. The decoding rule is that I will decode W decode W hat if W hat is jointly typical with the received vector and no other code word is jointly typical with the received vector. So in other words, decode W if TW hat occurs and none of Ti or I not equal to W hat. So in other words, remember that the code word that we sent, we're assuming that the code word that we sent is 1. So if W equals 1, an error occurs if so in other words, we could say decoding rule, decode W hat, so it's correct if T1 occurs and none of Ti occur for I not equal to 1. So an error occurs if T1 complement occurs or T2 union T3 union T4 union and so on up to T2 the NR occur. So, if these events occur, then one of two things will happen. Either T1 also occurs, in which case a decoding failure happens, or one of these occurs by itself, in which case W hat will equal either 2 or 3 or 4 or something. In any case, those decodings are not equal to 1, so therefore that's an error.